Hello friends. Now in this lecture we are going to discuss the point that is known as the Carnot heat engine. In this chapter, that is the thermodynamics, the name itself says that the conversion of heat energy into dynamics already we have discussed. So the heat energy can be converted into another form of energy, that is majorly it is converted into dynamics, that means mechanical energy. So now whenever you produce heat and you are going to convert that heat into the mechanical energy, then you need the engine, or it is also called as the total overall one system. That system converts one type of energy into another type of energy. So we can call it, that is the heat engine or engine is the machine which converts the heat energy into another form of energy, that is mechanical energy. Now Carnot developed one engine and the name given to that heat engine, that is Carnot heat engine. Although it is the ideal heat engine because it consists ideal gas. What is the purpose of to develop the Carnot heat engine? This Carnot heat engine, whenever developed, then it is found that the efficiency of heat engine is very low as compared to the efficiency of the other, that is what we expect from the heat engine. Now, already we defined the mechanical engine which converts heat energy is converted into mechanical work. Then the engine is called as heat engine. You know that the James Watt, in the name, that is James Watt, famous scientist who produced the steam engine in 1765, nearly about 1765 to 1768. So in that he used the water vapor as the material or working substance which converts the heat energy into mechanical work. Then it is found that the most of the engines what they are doing, that any heat engine takes the heat from higher heat reservoir. So heat engine, it takes the temperature from high temperature reservoir, and this heat is then converted into the mechanical work. It is the work, and some part, the remaining part, is given to the lowest temperature or the reservoir at low temperature. So this is the purpose of the engine. So what the engine does? Engine takes the heat from higher temperature, some part of the heat is converted into mechanical work, and the remaining part is given to the lower temperature system. So this is the working of the heat engine. हे तुम्हाला समजलं का बघा की नेमकं हीट इंजिनचं वर्किंग काय होतं. समजा तुम्ही एखाद्या गाडीला पेट्रोल भरलं, तर पेट्रोल आपण 1 लिटर पेट्रोल भरलं, पेट्रोलकडे काय आहे, हाय टेम्परेचर इफिशियन्सी हीट जास्त आहे त्याच्यात, आणि त्याला काय केलं, गाडी तुमची पळवली म्हणजे मेकॅनिकल वर्क केलं, आणि उरलेली एनर्जी म्हणजे कार्बन असेल, पाणी असेल, रिएक्शन झाल्यानंतर उरलेले काही जे काही एक्झॉस्टिंग आहे ते एक्झॉस्टिंग ह्या वातावरणामध्ये सोडलं. याचा वातावरण ह्या टेम्परेचर friction, low temperature. Right? So that means the heat energy taken from, that is the petrol, diesel, it is converted, partly converted into mechanical work, and the remaining part of that heat is given to the atmosphere, that means the low temperature system. Then it is shown that any engine working in this model, then it has the mechanically, the efficiency of heat engine is not more than 15 to 16%. Efficiency of heat engine is not more than 15 to 16%. That means if you provide 1 liter petrol, then the work converted into the mechanical work is only 15%. And more than 80% work is wasted. So how to increase the efficiency of heat engine? So now then, by using Carnot ideal gas, take an ideal gas and develop one engine. That is, I think the engine is the ideal engine one, considering the working substance is the ideal one. Then this engine shows that you cannot convert all amount of heat into the work. Some amount of heat is wasted in friction, viscosity and other purposes. That means developing some amount of energy. So that means the efficiency of heat engine is not always 100%. So efficiency of any heat engine must be lower than the 100%. Most lower than the 100%. Now we are going to discuss what exactly the Carnot heat engine consists. So this Carnot heat engine consists 4 different parts. First part is named as the working substance, or this working substance is a cylinder, gas cylinder. This gas cylinder is consisting the ideal gas. This is the ideal gas. All the surfaces of this cylinder is adiabatic surface, adiabatic boundary, I think. Adiabatic boundary. Adiabatic means no exchange of heat from this cylinder to the surrounding inside. But the bottom is perfectly conducting. This bottom is diathermic. That means heat energy can exchange from the bottom of the working substance. So this is known as the working substance of this heat engine. So I will draw the one by one here. So this is the working substance. You can name it is the working substance, or it is the cylinder. Cylinder consisting the ideal gas. Then this gas is heated by a frictionless piston. The side walls of the cylinder are adiabatic boundary. That means there is no exchange of heat energy with respect to surrounding. Whereas the bottom is perfectly conducting. That means it is diathermic boundary. That means whatever it may be, the higher temperature comes across by this cylinder by taking the amount of heat, then it gives to the surrounding immediately. So this is all about the cylinder, and this ideal gas is called as a working substance. The second part of the heat engine is the higher temperature reservoir, hot reservoir. It is called as hot reservoir. Hot reservoir. It is a material where this is a hot reservoir, you may say. This is hot reservoir containing the large amount of heat. Large amount of heat at higher temperature T. This is hot reservoir. It behaves as like a seawater. If you take a large seawater reservoir, then from that seawater, if you that is taken out some of the water, then level of sea doesn't changes. That means it is a large heat reservoir. Whatever the heat is taken from this reservoir, its temperature will not change. Its temperature will not change. That means it is called as hot reservoir. Next part, it consists the non-conducting platform. Non-conducting platform. So this is the material placed here, non-conducting platform, where when cylinder comes on this platform, then this performs adiabatic processes. And last one, this heat engine consists the sink, that is the low temperature reservoir, or it is also called as the sink. This is also called as the hot reservoir, is also called as source. Source provides the energy to the cylinder, whereas the sink, which is at lower temperature, is taking the energy from the working substance. So this is the sink at lower temperature T2. म्हणजे कार्नॉट हीट इंजिन याच्यामध्ये काय काय आहे बघा, कुठले कुठले पार्ट आहेत, 4 मेन पार्ट आहेत. एक आहे पार्ट सिलेंडर. सिलेंडर पार्ट काय करतं, सिलेंडर पार्ट कसा आहे, सिलेंडर पार्ट मध्ये आपण एखाद्या सिलेंडर मध्ये गॅस बंदिस्त केलेला आहे, आयडियल गॅस बंदिस्त केलेला आहे फ्रिक्शनलेस पिस्टन. त्यानंतर त्याच्या जी वॉल आहे, ती वॉल साइड वॉल काय आहे, adiabatic वॉल आहे, बाउंड्री आहे. याचा अर्थ त्याच्यातून हीट एक्सचेंज होणार नाही. आणि त्याचा बॉटम भाग काय आहे, तळ जो आहे तो काय आहे, परफेक्टली कंडक्टिंग आहे, दॅट इज डायथर्मिक वॉटर. And this total cylinder behaves as a working substance of heat engine. What it does, it takes the amount of heat from the hot and converts into mechanical work, and then remaining amount of work is given to the sink. So hot, that is the energy, heat energy taken from the source does some mechanical work at the non-conducting platform, and again remaining amount of energy is given to the sink where it is at lower temperature. So T1 must be less than T2. So this is the part. So this part is called as source. This part is called as non-conducting platform, and this part is called as sink. So overall, the Carnot heat engine consists of the working substance, the hot reservoir, that is called as the source having higher temperature, non-conducting platform, that means only it is a substance where when you put the cylinder on this non-conducting platform, then there is, what will happen, there is adiabatic changes takes place in the working substance. And when you put this working substance on a sink, then what will happen? The remaining amount of energy is given to the sink. म्हणजे इथं काय होतं बघा, की ज्यावेळी तुम्ही सिलेंडर इथनं उचलून इथं ठेवाल, त्यावेळी एका ठराविक टेम्परेचरला T1 एवढ्या टेम्परेचरला हीट एनर्जी याच्यातून ऍब्सॉर्ब करून घेईल सिलेंडर. ऍब्सॉर्ब केल्यानंतर काय होईल, एक्सपान्शन होईल. कारण एखाद्या सिलेंडरला आपण एनर्जी दिला तर त्याची इंटरनल एनर्जी वाढते, हे आपल्याला माहिती आहे. इंटरनल एनर्जी वाढणं म्हणजे इट गिव्स सम, दॅट इज द इंटरनल एनर्जी चेंजेस अकॉर्डिंग टू थर्मोडायनामिक्स, फर्स्ट लॉ ऑफ थर्मोडायनामिक्स, दॅट इज dq is equal to du plus dw. म्हणजे काय, this amount of heat energy provided to the working substance, then there is increase in heat energy and to do some external work. एक्सटर्नल वर्क जे आहे तेच आपण त्याला काय आपण म्हणूया, मेकॅनिकल वर्क. म्हणजे हे जे इंजिन आहे ते इंजिन इथं ठेवला तर इथं आयसोथर्मल एक्सपान्शन होईल. टेम्परेचर T1 कॉन्स्टंट आहे, कितीही त्याला हीट दिला तरी टेम्परेचर याचं बदलणार नाही, पण इंटरनल एनर्जी मात्र काय होत जरा वर्क डन मात्र होणार. वर्क डन मुळे काय होणार, मेकॅनिकल एनर्जी मध्ये कन्वर्ट होणार. नंतर मग तुम्ही काय करणार की सिलेंडर इथं ठेवणार, नॉन कंडक्टिंग प्लॅटफॉर्मवर ठेवणार. तिथं ऍडिएबॅटिक कॉम्प्रेशन होईल किंवा ऍडिएबॅटिक एक्सपान्शन होईल. आणि नंतर काय ठेवणार की सिलेंडर इज केप्ट ऑन सिंक वेयर द कॉम्प्रेशन टेक्स प्लेस आयसोथर्मली. आयसोथर्मल एक्सपान्शन, इथं आयसोथर्मल एक्सपान्शन, इथं ऍडिएबॅटिक एक्सपान्शन, इथं आयसोथर्मल कॉम्प्रेशन आणि इथून इथं परत उचलून ठेवला तर ऍडिएबॅटिक कॉम्प्रेशन. So in one cycle, there are two isothermal processes at the source and at the sink, and two adiabatic processes on the non-conducting platform. So this is the overall Carnot heat engine. The process and the theory of Carnot heat engine will be explained in the next video. Thank you.